Hello, and welcome to the first Belfast Kotlin User Group of 2021. So first and foremost, thank you so much, everybody, for joining us. One of the few silver linings of the current situation is that folks can attend remotely, and we can invite presenters from all over the world, as is the case today. So we have two great talks lined up for you, but a few announcements just before we start in. So thanks as ever to my co-organizers, to Ryan and Zara, who have been working away in the background as always. Then IntelliJ is now 20, and I can't believe that. So I first used IntelliJ back, it was an extreme programming workshop in the Guinness Enterprise Centre in Dublin, way back circa 2021. So I remember looking at all the refactoring functionality and being blown away. So can't believe that's been 20 years, you know, time flies. So related to that, JetBrains have set up a YouTube channel just for Kotlin. So that's all new and shiny. So we'll put a link to that into the chat. Then let's see. Yes, well, we no meetup in December, but we did a Kotlin Christmas stalking video where Kotlin and JVM gurus worldwide gave recommendations for their top Kotlin resources. So including our current presenters, by the way. Yeah. So if you haven't seen that yet, it's well worth your time. So again, we'll put a link into for that into the chat. We would like to do one of these meetups at least every other month in 2021. So if you would like to speak and or volunteer somebody to speak, then please get in touch with us and let us know. You'd be very welcome. And then finally, the other Belfast meetup that we helped to organise, Bash, has just announced the schedule for the first half of the year. So for details, see the Dev Bash feed on Twitter if we've put up the poster yet. It's either up now or it'll be going up very, very soon. So we've got some excellent speakers for the first 5 events, but we just have to get final agreement on the agendas and dates and so on. So we'll release the fine details nearer the time. But there are great things happening there as well. So that's it for the announcements. So without further ado, if I can call on Katie and Shelby for our first talk.
Hi. So we're so excited to be here. We're actually, I'm in New York City right now, and Shelby's actually in Boston right now. We're excited to kind of join you and you're part of the world today. So today we're going to present on the best of both worlds, both Kotlin and functional programming, and how you can use the two together to make your Kotlin code even better. So just to start off, I'm Katie Levy. I'm a software engineer at Amazon. I'm working in the Amazon Fashion org. I work primarily on creating size recommendations for different Amazon fashion products.
And I'm Shelby Cohen, and I'm a software engineer at Twitter and previously at Intuit. But now I'm on the search infrastructure team working on mostly backend services in Scala and in Java.
So here's our agenda for today for this presentation. We're going to cover, first off, what even is functional programming and why should you want to use it. We'll talk about how to make your Kotlin code more functional with some explicit examples. And then we'll also go into some more functional programming examples using Arrow, a functional programming library. And lastly, we'll have some more resources so you can learn even more.
So we wanted to start out by just sharing what functional programming is. There's definitely a lot of different definitions out there and a lot of different ways we can explain it. So we just kind of wanted to go over the main points of functional programming, which is treating code like mathematical equations. So with the same input, you always have the same output, composing a lot of smaller functions into larger functions, always trying to avoid shared state, mutable data, and side effects. And it's really good for multi-threaded support. And we just try to keep everything immutable because it makes our code easier to test. And so there's so much we can go into, but we're going to break it down today and show you how you can practically make your application more functional.
So the first concept that Shelby kind of hit on was pure functions. This is a big thing in functional programming. You want to make sure your functions don't have any side effects. So we can see here on the left, you have something which is an input and an output. For the same input, you're always going to get the same output. On the right, you have something that's more procedural. You have some side effects going on in the middle of the function. You might be referencing some external resource or external variable outside the function. You rather would want to have whatever you need for that function in the input for the function. And that's what makes your function more pure. So there's no shared mutated state. And it's very much like a mathematical equation. So this is a key concept that we want to kind of convey. Like, you need to make sure you try to make your functions as pure as possible.
So why do we want to use all of these functional programming concepts? It's because of a lot of benefits that they bring. So the first one is enhanced readability. And the second one is easier asynchronous programming. And because we talked about before, there's no shared state, so multi-threaded programming doesn't cause any race conditions, and you don't have to worry about memory leaks when using multiple threads because you're not mutating any part of your code, and no part of your code has side effects, which also makes it easier to debug and test because when you're referencing external variables in a function, that means that there's going to be side effects. And with functional programming, you don't ever want that. And so when you're writing a test, everything that you're testing is going to be the input of your function or the parameters you send in. And so you don't have to worry about, when you're maintaining your code and adding new features and removing features, you don't have to worry about what one piece of code is going to do to another piece of code. It's very isolated, which makes it way easier to continue refactoring and adding more code.
So how does this all relate with Kotlin? As you guys probably know, Kotlin is Shelby and I's favorite language, so we love talking about Kotlin. And some of the reasons why we love Kotlin are some of these. It's concise, it's safe, it's interoperable, it's tool-friendly, and so many other features that it has. We find that a lot of the core principles of Kotlin we see as the core principles of functional programming. So there is overlap, and it's cool that at the end of the day, you're just trying to create higher quality code that's easier to maintain and build upon with less bugs. And we found that Kotlin is an easy way to get into functional programming from an object-oriented background. So it's a nice way to learn functional programming or teach functional programming through the language and the way the language has been written to encourage functional programming. And that's kind of what we're going to talk about today. It is important to call out that Kotlin isn't a purely functional programming language like Haskell, but you can use functional programming concepts, or you can use object-oriented concepts, or a mix of both when you're writing Kotlin programs. But we're going to talk today about how you can get the best of both worlds with your Kotlin code and with functional programming.
Cool. So now we want to kind of jump into specific ways you can actually make your Kotlin code more functional. And the language really encourages you to do these things. You might already know what these things are, and you might already be using them. But you might have not known that it's making your code more functional. So these are built-in functions on collections, immutable variables, pure functions, and single expression functions.
So first off, the Lambda support and extension functions on collections is so valuable. This kind of is the Kotlin collections have specific functions on them that enable you to do more functional programming, and you can do function chaining with it using map, filter, fold, flat map, all these functional methods that we love to use. And this is powerful because we have functions as a first-class citizen in the Kotlin language. That means that functions can be stored as a variable, they can be used as arguments, and functions can be returned from functions. So you can do a lot with making your code more mathematical with functions, composing into larger functions to overall just make your whole program more functional.
So we're going to jump into the code now. We have here Java map and Kotlin map. We just put it for a reference, so if there's any Java developers, they can take a look at the left, but we're going to dive in to the Kotlin side on the right. So this is what Katie was just talking about. This is a function called +5 with the return type of a list of integers. We create a number list of 1, 2, 3, 4, and then we map over the number list and use this keyword that's built into Kotlin, it, to represent every item in the list, and we add 5 to every item in the list. This is really, really clean and concise, and it's really easy to chain multiple functions together this way. And one of the first ways we started using functional programming in our code was with map. So similarly, we have filter here. You'll notice it uses the same keyword it, but filter just keeps certain items in a list based on some definition. So here we are going to keep all items in a list if it's greater than 2. So you can just call .filter right on top of the number list. Very clean, and concise.
So here we have some Java code that's a function called getGreatestCities. And we're going to kind of play around with this function to make it first into Kotlin in a non-functional way. And then we'll show what the functional way to write it even is. And it'll kind of demonstrate how much more concise your code can be with a functional way of coding it. So first, just to explain the function, we have, we're creating an array list. We're calling it cities. We're adding a few cities to this array list. San Diego, Shelby and I both used to live in San Diego. Boston, that's where Shelby grew up in, and that's where she is right now. Seattle is actually where I grew up. So these are all near and dear to our hearts. So we're creating this array list of cities. We're going to loop through the array list, and we're going to look for Boston because Shelby lives there right now and she loves it. And then we're going to add this to another array list and return back that array list that just has Boston. So Shelby's going to refactor this into Kotlin.
Okay, so the first thing we want to do is create our list of cities using the list of operator, and we can just add in our list here. San Diego, Boston, Seattle. So now I can remove these 3 lines. We're also trying to make our code concise, but still readable. I'm going to zoom out a little. Now we have, we're defining our great cities, and then, oops, this should be greatest. And then we're adding to that list. But instead of doing that, we want to, let's see if it gives us the option. So something that we do a lot and something that's really good to do, especially when you're learning Kotlin for the first time and also learning how to make your code more functional. If you do Option Enter, if you have a Mac, and it pops up with these suggestions, because JetBrains is so awesome at their tooling and focused on making it a great developer experience. It gives you options like this one says we can replace it with filter map to, we can replace with a for each function call, we can remove the braces from the for statement. or we can use as sequence, filter, map to. A lot of different things will work here. There's not one necessarily exactly right answer. But if we do that, we can have filter and map to. So now it's thinking we want to use this array list, but let's just change this to a list of strings, and let's do some of our own editing. We can say cities dot filter, and then we want to filter. We don't need to say it is no longer the index. It is just the item in the list. So we're going to say filter if it equals Boston. And then we don't even need to do a map to. And we're going to return great cities. This will also give us an option with the little squiggly line underneath to say, hey, you can inline this variable. So we'll inline it. And now we've gotten something down to very concise code. We're using filter and we're using our keyword it. But I think we could probably make this even better. Let's see. Let's inline this list just to show you what it would look like. And then we don't even need this return keyword with the return type. So Katie talked before about single expression functions, and we want to use those as much as we can to make our code look like mathematical equations. And if we move it and we delete the return type, I think this is a great example of something that would be perfect with a single expression function. There's not a lot of stuff happening here, and it's very straightforward. And now we got it down. It is one line, but I want everyone to see it, so we're going to leave it zoomed in. But yeah, Katie, do you have anything to add before we jump back to the slides?
Yeah, it just shows how concise it is, and you can write Kotlin code that is like similar to Java, but you can also do something like this in Java as well. But Kotlin makes it a lot easier. You don't necessarily need, for those of you familiar with Java 8 streams, you don't need the collections to stream to start off the stream, and you don't need the collect at the end in Kotlin. You can just write, you can operate on the list with the filter function that's already added to the collection. And then you don't need the collect at the end. So it's super concise in Kotlin and super, super easy to read and then use throughout your code with a single expression.
Awesome. Okay, so I'm going to jump back to our slides.
Props to Shelby for doing some live coding in a presentation. So next we'll kind of talk about flat map, which is another great functional programming method. So map and filter are kind of good ones to start with to get familiar with the concept. But flat map is a great tool too. So this would be, like in this example, we kind of have two lists, and they both have integers inside of them. And then we have a list of lists. So that list, it's called in here number list, has two lists inside of it. And we want to operate on the elements, the integers, and add 5 to it. So in Java, this is what it would look like with that dot stream that I was talking about, and then the collect at the end. Whereas in Kotlin, we can just do the flat map on the list of lists. And then we also have inline operators. So that +5 inside of the flat map on the right is actually adding 5 to those whole inner lists, which actually is adding 5 to each element in the list. And then it flattens it at the end. So at the end of this, we'll have one list with just integers that has 5 added to each integer in the inner list. Kind of hard to talk out loud and explain it, but the code kind of portrays it a lot, and it shows it's so concise in Kotlin. And FlatMap is just a great tool to have in your toolbox when you're doing these different chaining functions or operating on things in a functional programming way.
Next, we have immutable variables. So most of you probably know this unless there's any Kotlin newbies on the call, but you can define immutable variables with val, and then if you mutate it, it will be a compilation error instead of a runtime error. And if you want to define a mutable variable, which we don't recommend, then you can use the var keyword.
And similarly, we have immutable collections. So if you define a list of something, you can't off the bat mutate that list. You have to explicitly define the list as a mutable list of. So this makes it very explicit when you want something to be mutable and immutable. And like we've said, functional programming, you want to have things as immutable as possible. So try to go through your code and make things list of instead of mutable list of. And then you can use like the map filter, flat map to operate on the list to actually create new lists when you want to change them, not change the existing variable that you already have created. So this is a great way to make it very explicit and to know what is mutable and what is not.
So another way Kotlin encourages immutability is expressions, not statements. So one example here is using the when expression. So we have a function foo that takes a parameter and it returns a type string. So since we're using an expression body, we see we're setting it equal directly to the when expression. And so it's going to return directly from any of these logic blocks. So we're going to say when the parameter is 1, we're going to return the string 1. When it's 2, we're going to return the string 2. And then if it's something else, we're going to return this fun string that we don't know what the input is. And the cool part about this is if you changed any of those strings, 1, 2, or the I don't know string, it would be a compilation error because it's not matching that correct type we need to return. And also if we had removed the else and didn't have that there, it would give us a compilation error that we need to have an else branch, unless we're using something exhaustive like an enum. So this is really cool because you get a lot of real-time quick feedback when you're using, when you're trying to write an expression. And you can do this with if expressions as well, and it encourages you not to mutate along the way based on different conditions.
And here we have single expression functions, which we kind of showed you earlier with the greatest cities. So you don't necessarily need to have a function body block. You can just have the expression after the function definition in the same line. So this makes things so concise and encourages you to kind of break up your functions into smaller functions, which is a very functional programming concept. You want to combine smaller functions into larger ones and compose them all together. So if you can write a function in one line, you can clearly say like what the logic is and the function name, and it's easy to read, easy to use around your code. So this is also one way that Kotlin really encourages functional programming through just the way that the language is built out. So just to kind of wrap up this section, these are the kind of different areas we hit on and different ways that you can make your code more functional. So using the built-in functions on collections, those things like map, flat map, filter, there's a lot more on there. I encourage you to look at the actual collection class itself and look at the different methods inside. There's a lot of great functions you can use there. And then we hit on using immutable variables when you can. So that's using the val keyword as much as you can instead of var. And then using pure functions with no side effects and no state, using these expressions, the when, if, and single expression functions, just having one line of code that has what logic you're trying to portray just in one expression.
So now that you've got down how to make your pure Kotlin code functional, we wanted to talk about Arrow, which is a functional companion to Kotlin's standard library. So we both started using Arrow once we got comfortable with Kotlin and once we got comfortable using some of the things we just showed you in Kotlin. And there's a lot here in Arrow. And so, you don't need to add it all at once. And so we're here today to kind of show you how you can introduce Arrow to your project, start to use some more types and abstractions that are going to make your code even more functional, and do it in kind of approachable way that you'll see the benefit right away.
Yeah, so if you just look at Arrow off the bat, it might kind of sound scary, the different functional programming words that are used, but you don't necessarily have to use everything in the library. And it's really important to note, this is the key mission statement for Arrow, is to empower users to write pure functional programming apps and libraries built atop higher order abstractions. So really, we just want to make your code even more functional than it already is by using some of the types that are in the library. You can pick one and start from there. You don't have to kind of add everything in at once. So it can be a progression, but it's a great tool to just help make your code even more functional in Kotlin.
So the first type we started using is an either type. So we wanted to go over what that is. It either has a right and a left value. And so you can have a type for the right and the left. And typically the right holds successful values. So you'll see here we have this variable right, and it's defined with the either type with string on the left and int on the right. So if we call either.right with a 5, we'll see if we're calling right, it returns right with b equals 5. That's because A is equal to the left side and B is equal to the right. And then you'll see below the left variable here, something went wrong, is a string, and that means it's an error, and the left side is defined here as a string. So we have left A equals something went wrong. So we kind of went over that quickly, but we already know what map and flat map and filter are. And so we can do all of those operations on an either type, but it's only going to happen on the right side. So it's only going to happen on success. So this is really useful because maybe you want to chain a bunch of operations together, but you only want to operate if the previous thing is successful. So if you have all your functions returning this either type, it's very easy to operate only on success and then cancel and return if there's a left and it fails.
Awesome. So with the either type, we kind of can think of it as a sealed class, which is nice. You kind of have one or the other. And coming back to the functional programming concepts, exceptions are just not a great fit for functional programming. They kind of create side effects and disrupt the program's flow. So it's really not. It's really discouraged to use exceptions when you're trying to use functional programming concepts. So you might ask, well, what do we do instead of exceptions? You have these sort of error types that hold the error value and can tell you that there is an error without causing this disruption and side effects that exceptions have. So we're going to walk through an example of using this either error type through Arrow to demonstrate different errors in your code flow. So here we have a few different functions: parse, reciprocal, and stringify. Parse is just taking in a string and it's parsing it into an integer. There's a possibility that we could have a number format exception. So you might have something like this in your code where you're throwing a number format exception when there is not a valid integer. In the reciprocal, we're taking an integer, getting the reciprocal of that value. You can't take the reciprocal of 0. So we would throw an illegal argument exception at that point in time. And then we have stringify, that is just turning the double into a string without a function or without an exception in it. On this next slide, we can see how you might change this to use the either type. So that first function, parse, we're, instead of returning an integer, we're returning the either type, with the left being a number format exception, which is the error case, and the right being an integer, which is the success case. So we know we're going to get either a success or error, and if it's an error, we know it will be a number format exception. So here, once we're in the error case, in the else, we return back the either dot left of that number format exception. So the number format exception is wrapped inside of the either object. And then for the success case, we have the either dot right with the integer wrapped inside of it. So we wanted to try out hearing from the audience on how what the output for this function would be with the specific input. So I think you guys can post in the YouTube comments, what would this this function taking in not a number result in? What would be the output value of this function call? We'll give it a few more seconds for you guys to think.
Here we go. We got some answers.
Yeah, so this would be an either dot left. Yeah, oh, you did the second one too. So the first one, the not a number, since not a number is not a number, we're going to end up with the error case, which will be the either dot left of a number format exception. And then the next one, if you guys want to answer what the next one would be, parsing to. Yeah, you're right, with the left and then the right. So the first one's the left with the error, and then the second one, parse to, is a right. So we'll have the either type of right with the value 2 wrapped inside of it. Awesome job. So to make things a little more complex, now that you guys kind of have your feet wet, we have these other functions, reciprocal, if you guys remember, where we're gonna have the either as the return type again, with the illegal argument exception, the error case, double as the success case, and we'll just put that either dot left where that exception was thrown and wrap the exception instead. And then we have stringify, which is just parsing the string. And then we have magic, which is a cool function. It's going to return back the either type of exception or string. So it can be a various different number of exceptions. So we're kind of making it a broader type. And this function will parse a string. If you remember from the last slide, that could end up with a number format exception. And then we'll do flat map on that either type and get the reciprocal of that value. And remember, the flat map only happens on the success case. And then we'll map and stringify that value to return back eventually an either of a string if it's a success and either left on an error. So can you guys figure out what this first one, magic of 0, what would this output be for this function call? Give you a few seconds to think. Cool. So flat map is right opinionated, and the first one is a left. Yeah, that's correct. So we'll have a left type on the illegal argument exception because you can't take the reciprocal of 0. So how about the next one, magic of 1? So we have get the string at the end. Yeah, that's correct. So we'll end up going through the whole flow of magic and write of string. Yeah, so we'll end up with an either dot write with the string inside, which will be a 1. Reciprocal of 1 is 1. So we'll end up with write of 1 inside. So how about for not a number? This one's a little trickier because the function, the exception's not on this slide, it's on the previous slide, but I can tell you if the input is not parsable to an integer, it will throw a number format exception. I feel like it should be called wrong, not left. Yeah, it would be wrong and right. Runtime exception. So it won't be a runtime exception because we explicitly will say if Shelby, if you go back to the previous slide real quick, if it's parsing it, we will check if it matches the regex before we actually parse it. Yeah, left exception. Cool. So we'll have a left of number format exception. So this really shows how you can use the either in the return type. And next, we'll make things a little more complicated with this larger function. So magic was the function we were just talking about, where we're getting the reciprocal of the value, and then we want to operate on the result. So in this past, we were getting the output of 2. Like if we had the either dot write of 2, we can check with the when expression what the return type is. So it's either going to be an either dot left, which is the error case, either dot right, the success case. And from there, we can dive into the specific error cases by doing another when on the actual exception types. And from here, we can say like what we want to return as a result of the specific exception without actually throwing the exception and interrupting the program flow and causing side effects. So this is a really powerful way to add ethers into the flow and then operate on the return value, which will be either an either dot left or an either dot right.
So jumping into some Java code here, we wanted to show you a good place that you could replace using ethers and also writing some Kotlin. But we saw this a lot in our Java services we worked on when we worked in Java. And a lot of mutation is happening here. We have a try catch, and in the try catch, we're checking if a certain status code from a first service is 200. And if it is, we're going to call a second service. And I don't know how many of you use Java, but I'm sure you've seen some sort of similar work in your code, whether it's checking a status code or any kind of if statement that's nested with lots of mutation. And this is really hard to test. This is hard to debug. This is hard to refactor. And so we wanted to figure out a way to make code like this better and easier to read. So this is one example of how we would use either. So we have this function call first service, returning an either of a string or an int. But you can make the return types anything you want. So you might have your own data class with your response object, and you might have a success response and then an exception for the error, or maybe it's another response object. But we're setting the status to 200 here, pretending that maybe that status was going to call an external service. And then we have a return when, and we check, is the status 200 or 201? And that is going to return an either dot right with the status. And if not, it will return an either dot left with the error. And this is really great because we're returning the same type everywhere, and we know we're defining what success is at the lowest layer of the code. So there's no more checking if something's equal to 200, wondering if we should also check 201, or just wondering what success is because it's encapsulated in the actual type. So right here, we have another example where we have call services. We set the response to the first call first service function that we just showed. And then we use is either dot right for smart casting. And right now we're not using the response, and Katie showed another example of this before, but this is just to show you how, there's only one success in one error, and this when expression is exhaustive. And so that really helps eliminate any worry that you're not sure what the definition of success is in your code. And you know that if you forget a right or a left, it's exhaustive, so it will be a compilation error instead of a runtime error. So some key benefits from using arrow data types is status checks at the lowest layer. So we just mean that at like the lowest layer of your code, that's where you can do all the complicated logic to figure out what we should trampoline back up the stack. And we're going to handle errors with types rather than exceptions. And even if you're using exceptions, it's wrapped in the same type, and so that's okay. And then we're going to avoid mutation, and all of these types starting with either encourage that. There's definitely lots more we could go into with arrow, and we've slowly introduced more and more, and it's helped make our code more functional. But this is a really great way to start. You're probably already doing some of the Kotlin functional programming we showed you. So if you introduce arrow, it'll be really fun to play around with it and get started.
Awesome. So that is our way of showing you how to use functional programming in your code in Kotlin. Starting today, you can kind of dive into it with some of the examples that we have. And here's a place where you can learn even more. So we recently were on Lambda Show podcast. You can hear us talking on there about functional programming with Kotlin, why we love it so much. And then there is a great book that we use to actually learn functional programming in Java. And that's where we were learning Kotlin at the same time, but this was a way for us to learn functional programming and then bring it into our Kotlin code too. So it has a lot of good insights on, even if you're writing Java code as well, how you can make your Java code more functional, but also concepts you can apply to Kotlin. And then we're really excited about this book that's going to be coming out, Functional Programming in Kotlin, summer of 2021, which will be nice to see the specific examples of using functional programming in the Kotlin language. Probably, something similar to what we've kind of showed you today with some of these examples, but even more that is more Kotlin specific. So keep an eye out for that book as well. And that is it for us. You can follow us on these are our Twitter handles, or message us with any questions you have, or tag us with whatever you're talking about that's Kotlin or functional programming related. We'd love to join in on the conversation. And thank you guys so much for having us today.
Cool. That was absolutely amazing. Thank you so much. And thanks for getting interaction out of an Irish audience, which is hard to do. So a star for that. Just a few little questions. First of all, put you on the spot, okay? Once you get really used to and comfortable with functional programming, what features of Java or Kotlin don't you like? You know, so what little bits of Java or Kotlin do you wish that weren't there or were slightly different or something like that?
Yeah, I would say off the bat, exceptions, just because so many of the applications I've worked on, it's just embedded in the code flow to have the exceptions, and changing it to the either type. You kind of need to get everyone on board with it, and you can do a slow progression too. It's not like a full-on refactoring, but that's been kind of a tricky concept for me to really get across to some people that have been using exceptions for years and years and years. And it's powerful to have the either type, but since it's there, like, people get so comfortable with it and familiar with it. So that's one I would call out for sure.
Cool. Very good. Any others?
Yeah, I would say it depends what version of Java you're using. So we think, Java 11 and Java 12, they've added a lot to be able to write functional code. But even just mutability and constructing lists, things like that in Java 8 are definitely why we were kind of pulled to Kotlin, because it's so easy to focus on immutability.
Very good. You're going to make me sound really petty now. Mine is putting a double colon in front of something when you have to take the address of a function. It just really annoys me. I know why it's there, and I know it's there for safety and so on, but it's just like glass in my eye. It just annoys me. But yeah, that sounds really petty. The other question was, have you seen people taking it too far in Kotlin? Because I know with functional programming in general, sometimes you get people who use a lambda for everything and stop using loops as a point of principle, and the code gets very small and very bitsy, or everything's done in one line. It's just that line is 5,000 characters long. So have you come across anybody taking it too far?
Yeah, I think there's always sometimes you take it too far, but I think the most important thing is just to focus on writing good code, good quality code and good tests. And if you focus on that, I think it naturally has you break up your functions and not have one really long chain. But I think as everyone on this call is learning about this now, so if you see someone doing that, definitely, leave comments on code reviews, help people learn. Some people do that when they're first starting to learn functional programming because they get really excited that they can chain everything together, and the functions become really big or too small, I have seen. So I think just focusing on writing good code. I like to think of writing my code like I can read it like English. And so if you're kind of approaching it that way, then it's a lot easier to know. If you can't understand what you just wrote, then you probably should edit it more.
Absolutely.
Yeah, and to add to that, some of the arrow concepts that we love so much might have a little bit of a learning curve for people to understand. So that's really important to make sure everyone on your team kind of knows what's going on with this type. So really have to make sure everyone learns it before you throw it into the code and then people get nervous to touch it. So I think sharing that knowledge among everyone makes it less scary, and everyone knows how to operate on it. So that's a really important thing, because you've seen people get really excited about these different types and different features in Arrow, but not necessarily teach other people about it, and then it's kind of like an elephant in the room of what is this? But yeah, just kind of sharing the knowledge is really important as well.
Very good. Very good. And there's one last thing there. I'm just looking at the comments. Why not use try rather than either? I actually know that one. So I believe try is deprecated, if that's right.
I think try is deprecated.
Yeah. So there was originally a try structure, and I had it in some of my code, but I think it's deprecated because it is the same as what you were doing, and either with the left of exception. So I think they're going to take it out at some point. So, but I think it is in other languages. Cool. Very good. Listen, that was absolutely brilliant. Thank you so much. We'll bring you back at the end for the group questions. But if I can banish you for now, and if I can call on Kate to do our second talk.
Hey.
If you want to just introduce yourself and then work away.
Yes, sure. First, I'm excited to be here today. I think as we all, I miss offline events so much, but on the other hand, it's so exciting that we all have this ability to join any Kotlin user group just with one click. So right now, I'm in Russia, and it's really cold here right now, about minus 20 degrees, I think. So, but I won't go outside today. And instead of this, I'll be glad to give you a talk, not very short, but I hope we will fit the timing. I'm a developer advocate for Kotlin. And today in this talk, we are not going to spend much time discussing why you should try to make your applications cross-platform. Because don't repeat yourself is kind of a mantra for the most of us, including Alex and Anne. They're in love with mobile development, but neither of them likes doing the same job twice. So today we will help Anne and Alex to take a journey into the wonderful world of cross-platform development, and we'll see how we can use Kotlin Multiplatform Mobile along their way. And one disclaimer first, this talk is mostly an intro to development with Kotlin Multiplatform Mobile, so it will be most useful for those of you who don't have much experience with this technology. But I hope that experienced KMM users, if we have some here today, hi, would also find something for them. For example, maybe some ideas about how to introduce KMM and explain all its features to their team. So today we'll take a look at all the different stages of mobile application development and learn how to use KMM features to optimize them. Next, to make the picture more realistic, we also will discuss obstacles you may face if you decide to integrate your KMM into your project. And of course, we are going to discuss how to overcome them. And finally, to give you even more inspiration, I will share with you some insights of how KMM adopters are using KMM, because it's a flexible technology and there are hundreds of ways to cook it. But first things first. I'm sure that some of you have heard or maybe even used Kotlin Multiplatform or KMP, and some of you have heard about Kotlin Native. To make sure we're all on the same page, let's make things clear first and figure out what Kotlin Multiplatform Mobile is. So, Kotlin Multiplatform Mobile is an SDK for cross-platform mobile development. It uses the multi-platform capabilities of Kotlin. It includes various tools and features designed to make the end-to-end experience of building mobile cross-platform applications efficient and enjoyable. KMM allows you to use a single codebase for business logic of iOS and Android apps. And you only need to write platform-specific code where it's necessary, for example, to implement a native UI or when you're working with platform-specific APIs. We will talk about it and I'll give an example a little bit later. So KMM is seamlessly integrated with your mobile project. Shared code written in Kotlin is compiled to JVM bytecode with Kotlin JVM and to native binaries with Kotlin Native. So you can use your KMM business logic modules just like any other regular mobile library. And KMM doesn't impose any restrictions on how you develop your application's UI. The simple statement KMM equals Kotlin Multiplatform plus the mobile-specific stuff around it. What is the mobile-specific stuff? The best example is the KMM plugin for Android Studio, quite fresh, which allows you to write, test, run, and debug shared code in the same IDE. We will also take a closer look at it a little bit later. When it comes to cross-platform development, it's always a choice. KMM is not the first and definitely not the last technology of that kind. And I want to spend just a moment talking about the variety of options available and compare them a little. Not to select the best, but to understand what kind of project KMM is best suited for. So let's take a look at the architecture of a standard mobile app. Basically, it consists of several layers: UI layer, presentation layer, business layer, and data access layer. If we imagine a scale where the bottom point is core and the top point is UI, we can see that the most popular cross-platform approaches are UI-centric. What does it mean? Well, it doesn't mean that you can't write business logic code. Of course you can, and there are a lot of examples how to do it. But it means that the whole ecosystem is focused mainly on developing UI components. But when you decide to write something more complicated than just sending HTTP requests, you will be almost alone in this wild, vast cross-platform world because of the lack of libraries and practices. However, these technologies allow you to create similar interfaces for your apps very quickly. So this approach is absolutely justified when you have simple apps, thin clients, or if you just want to make an MVP to test your product assumptions. But when your product starts to grow, the UI quality and responsiveness requirements usually get stricter, and the business logic becomes too complicated for UI-centric approach. And this is where the business logic-based approach comes in. We already have some well-known players here, such as strategies to have shared C++ or JavaScript code. And as always, they come with different advantages and disadvantages. All core-centric approaches assume having an ability of integration into the existing project. Because, well, you need to write UI layer for them, so that kind of approach, for that kind of approach, your legacy code base is not a blocker anymore. But one of the most harmful disadvantages is the need to add one more additional language to the existing code base, together with its own tooling, ecosystem, and rules. And this doesn't seem like the easiest way to avoid duplicating some parts of your code. But when you could write your all business logic in Kotlin, it's not a problem anymore. So with Kotlin Multiplatform Mobile, our characters, Anne and Alex, can immediately start sharing business logic between iOS and Android applications in any project without any limitations on the UI development process and, what's most important, in their favorite language. Sounds good, I think, so let's have a look. How many of you have been thinking about starting a new pet project to try out some new cross-platform approach during these Christmas holidays? Alex is no exception. He loves space, so he wants to create a mobile application that will get information about SpaceX launches, store it in a local database, and display it in a list. Well, yes, it's quite simple application, but as always, it's just the beginning of the big story. So together with Alex, let's go through the development process of a typical mobile application and see how we can use KMM to make it cross-platform. On the first architecture design stage, we need to decide what parts will be shared and what parts will remain native. Let's go back to our architecture diagram. KMM is designed to allow you to share the business and core layers of your app. When we are creating a new mobile app, we don't want to spend a lot of time thinking about organizing our data layer. It's such a common task, so that there should definitely be some building blocks to do it quickly. So KMM provides exactly these building blocks. The ability to use platform-specific APIs along with the expect actual pattern allows you to create them without reinventing the wheel. The Cater HTTP client is a good example of such a block. Like all multi-platform libraries, it provides several artifacts, one with common logic for all platforms and drivers for different platforms, which allows you to use the platform native capabilities to perform HTTP requests. The other building block we need is Kotlin serialization, which we will use to deserialize JSON responses into objects of entity classes. And the last one is SQLDelete. This will generate Kotlin code from SQL queries to create type-safe database API, which we will use to communicate with databases on iOS and Android devices. As a Cater library, besides the core artifact, SQLite also provides platform-specific database drivers for Android and for iOS. Next, for the domain layer, let's add a couple of entities. And in Alex's case, there should be entities for rockets and launches. And let's also add wrappers for Cater and SQLite libraries that will allow us to get the data as business entities and hide some core details. The entry point to the KMM shared model will be the SpaceX SDK class, a facade over our networking and caching service. Now we have the mobile SDK, which could be used in our application. And it can also be easily distributed as a separate mobile library to allow other developers to create clients for our web service, for example. This is very simple KMM module architecture, and it's quite enough for Alex process, but of course you can create more layers of abstractions and make your code even cleaner. That's it. The rest to do is just implement our architecture in Kotlin. With the help of Gradle and Multiplatform Gradle plugin, we will get the needed artifacts for our Android and iOS projects. There are different approaches of how to deploy these artifacts to your mobile projects. If you have a monorepo, it's the simplest case because you could just use single Gradle project for both the Android and shared modules, and for iOS you could manually configure Xcode by linking the generated framework, or you can use CocoaPods plugin, for example, and add dependency to KMM pod, just like it would be a local pod written in Swift or Objective-C. Let's now take a look at the build Gradle file of the shared module to better understand the KMM project structure. There are three main parts of any Kotlin multi-platform project: targets, source set, and compilations. A target is a part of a build that is responsible for building, obviously testing, and packaging the application for a specific platform. Source sets are collections of Kotlin code files along with their resources, dependencies, and language settings. In common source set, you can use only Kotlin stuff. However, to implement the same logic on Android and iOS, you sometimes need to write two platform-specific versions of it. For example, to access data which is stored somewhere on the device. And to handle such cases, Kotlin offers the expect actual mechanism. So your expect declarations goes to the common source sets, while actual implementations goes to platform source sets. In our case, it's Android main and iOS main source sets. And this is where you could use any platform dependencies. For example, you could add dependency to HTTP library for Android and to IF networking for iOS. A source set can be used in Kotlin compilations for one or more target platforms. And the last thing, each target can have one or more compilations, for example, for production and for testing purposes. That was quite complex stuff, but let's look at the declarations at our configuration, and it will be quite concise. So in our cross-platform mobile project, we need to declare two targets, Android and iOS. The common dependencies that are used in all targets need to be declared in the common source set. In our case, the Cater, Kotlin serialization, Cater serialization feature, and the SQLite runtime. And since Kotlin 1.4, stdlib is added by default to any Kotlin Gradle project, so there is no need to declare it explicitly. You don't need to specify dependencies on different library variants in all source sets where it is used. You should specify dependency on them only once in the shared source set. However, we still need to explicitly specify dependencies on Cater's engines and SQLite drivers, because there are many of them, and it's impossible to determine automatically which of them to use. And the last thing about our configuration, this tiny iOS declaration hides some tricky KMM module configuration details for the iOS target. The thing is that iOS simulator and iOS devices currently have different processor architectures. So to be able to run and test our app on both of them, we need to compile our shared code for 2 targets, not for 1. But good news that you don't really need to think about it while you're working on the shared code for your mobile apps, because everything just works out of the box. So, configuration is finished. I'm sorry, I think the presentation is gone, and I will share it again while we can think about this, I hope, not very complex configuration. So just one more second. And here it is. Let's find our slide. Oh, yeah, it is. Interesting thing that the presentation was broken right after our configuration, but in real world I hope there will be no problems. So, configuration is finished, success, but before we start writing code, let's discuss our architecture a little bit more. I know for mobile developers, for example, discussing different architectures is considered to be a hobby. But jokes aside, we've discussed core and business layers. But what about presentation layer? This is the common question. Do we need to share it or not? We definitely can do this, and there are already many community libraries that allow you to do this and have plenty of examples of their usage. But you need to think carefully. Do your apps look similar enough to have one presenter or view model or controller for both of them? Could this change? I'll let you make the decision for yourself about your apps, and today we will go only with shared business logic. And after all, it's never too late to do some refactoring and move more layers to the shared model if you are sure that it's worth it. So, our application architecture is now designed, and we know how to configure our project. Let's finally write some code and discover some KMM features. Of course, KMM is seamlessly integrated with Android. You use Kotlin for every part of your project and work in the same IDE both for shared code and for platform code. But we are writing our business logic code for both platforms, not for one, and KMM also provides tight integration with the iOS development process. Thanks to Kotlin native bidirectional interoperability with Objective-C and Swift, you can call Kotlin code from Objective-C or Swift, and you can use iOS libraries from Kotlin. You can integrate KMM modules in a natural way for iOS developers using CocoaPod's dependency manager, as I mentioned before. And with the KMM Android Studio plugin, you can write, run, test, and debug shared code all in Android Studio. And you can run it both on Android emulator and on iOS simulator. So let's take a closer look at these features. Alex created a single function in the SDK class, which returns the list of launches from the database. So we can easily use our KMM module API in Swift. Kotlin's list is mapped to Swift array, so calling this function looks very natural. And iOS developer even can suspect that something is wrong with the model, and it's written in Kotlin. But before getting the cache data, we need to load it somehow. So we need to make an HTTP request. getLaunches is a suspending function, so our public getLaunches function needs to be marked as suspending too. There is no such concept in Objective-C or Swift, but you don't need to worry about it. Suspending functions are available in it as functions with callbacks. That pattern is more known in the iOS development world. So when you have such functions in the generated frameworks header, you can call them from your Swift or Objective-C code, and you can even override them. Our HTTP client can throw an exception during the get-or-launches call. There is a fundamental difference in error handling between Kotlin and Swift. All Kotlin exceptions are unchecked, while Swift has only checked errors. Thus, to make Swift code aware of expected exceptions, Kotlin functions should be marked with a throw annotation, specifying a list of potential exception classes as a parameter of this throws annotation. Now we can handle all exceptions in our completion handler in Swift code. This was just a small example of Swift Objective-C interop possibilities. It supports all fundamental concepts, and I think the most important thing about it is that it doesn't require any additional setup, allowing you to integrate the KMM modules into your iOS project without a headache. Kotlin Native also provides integration with the CocoaPods dependency manager. You can use KMM modules as a CocoaPods dependency, or you can add dependencies on pod libraries stored locally or in the CocoaPods repository. And you even can manage pod dependencies directly in Android Studio. And on the subject of Android Studio, with the KMM plugin, you can create a UKMM project or module just with a few clicks, and you can get integration with your iOS device and simulator directly in Android Studio. This is a small demo. With a new Kotlin Multiplatform Mobile project wizard, you can create a ready-to-run mobile application project with a shared codebase in just a few clicks. This generated project will contain examples of how to connect to platform-specific APIs and basic test coverage. This is a really great tool to start exploring some KMM features. And you don't need to switch IDEs and even have Xcode running to check that your business logic code works correctly on both mobile platforms. You can run and debug your application and test on the simulator on device with a predefined run configuration. And the last stage, after writing our code, we want to test and deploy it, obviously. And I think you'll be glad to hear that there are no big differences in this process, as your shared code is connected like any other regular dependency. And I think one difference, if you want to maybe optimize your manual QA work right now, it's because the business logic code is reused and you don't need to test some features on both platforms, and you only need to do it once. So, congratulations! We've designed the architecture of our application, created a project with a KMM plugin wizard, written some code in Kotlin, and integrated it in both our iOS and Android apps. You can find the complete project with a step-by-step tutorial at our hands-on portal and use it as a guide to creating your own KMM applications. And Alex and Anne look really happy because now they definitely know how to stop duplicating code for mobile platforms. And they've learned that it's time for Kotlin Multiplatform Mobile. And everything sounds great at this stage. But you know, a lot of such talks usually feel like a drawn and old story. Everything is easy on the first step, but when you want to create something more complex than just basic examples, then everything becomes not so smooth. Of course, you will face some obstacles on the way of integrating KMM if your project is rather complex and your team is rather big. But in my experience, it's a common thing for any kind of technology. Based on my experience and the experience of lots of KMM adopters, these are the most popular obstacles that the mobile team faces. Some of them are technical, such as JVM and native words differences, Objective-C Swift interoperability issues, and Kotlin native compile time. As you can see, they all related to the native development with Kotlin, and I think it's quite expectable. Kotlin originally was a JVM-based language, and that's why integration with Android world is smooth just out of the box. And you could also face an organizing team challenge, which is more process-like. And it's a usual thing when you're integrating new technology into your code base if you're working not alone and you're working in a team. But forewarned is forearmed. So let's go through these challenges and see how Kotlin team addresses these issues and what you can do right now to overcome them. When we speak about Kotlin multi-platform programming, here is a tricky thing. It's the same and not the same Kotlin simultaneously. It uses different compilers backends under the hood to be able to run Kotlin code both on JVM and on native platforms. That's why the realization and behavior of some things can be different. And I think the most vivid example is the memory model realization. It greatly affects the experience of working with concurrency. For example, your code can work perfectly on Android, while you will get invalid mutability exception on iOS. And it could scare you a little bit, especially when you have no idea what is there under the hood. So how to overcome this? First, I suggest you to learn some basics at our documentation portal. It's much easier to work with Kotlin native concurrency when you understand how it works. There is a set of articles describes Kotlin native concurrency rules, how to work with them, and also suggests different approaches to work with concurrent code in KMM projects. One of this approach is try to manage concurrency only in the shared code and make calls to the KMM library only from the main thread from your iOS and Android code. If you combine this approach with using the concurrency libraries, such as Kotlin X coroutines library, you would avoid the majority of potential problems and everything will work smooth. One thing, to use coroutines on multiple threads in native world, currently you need to use special version of the library. This special version is living in a separate branch of Kotlin X coroutines repository. It may look strange, but it's absolutely safe to use it in your project because it will get continuous support until Kotlin team implements the new Kotlin native memory management model. Because now using multi-threaded coroutines may result in memory leaks. This can be a problem for very complex coroutine scenarios under load. So the new Kotlin native memory management model is on the roadmap, and team is working on a solution for this. The next obstacle some users face is some, I would say, unexpected things about how interoperability with Swift and Objective-C works. Here are some of usual complaints. How enums and seal classes are represented in the generated headers, or that there is no default function argument support, or some issues with primitives. And my first advice here, it may sound strange, but just be ready. I'll explain. At a first glance, Kotlin and Swift look very similar, and you expect that you will be able to work with every Kotlin construction in Swift as usual. For example, I was very surprised when I created a companion object with a single function in my Kotlin code, and I didn't find a corresponding class member static function in the generated Objective-C headers. But then I realized that it's reasonable because companion objects, they are, well, objects, and they can, for example, implement interfaces. So this doesn't seem correct to unconditionally export all object members as class members. Another example of fundamental differences between Kotlin and Swift is exception handling, which I described earlier. And when you realize these differences and when you've learned about some annotations, some useful annotations, it becomes easier to handle it. If you are using a language feature, Kotlin feature, and there is no such concept in Swift, you simply could create wrappers in your shared Kotlin code. For example, before Kotlin 1.4, suspend functions weren't supported in Kotlin native Swift and Kotlin native interop. But it doesn't mean that you weren't able to use it. You could create a simple wrapper function for them. And as I mentioned, since 1.4, this support is built in. And for example, if you don't like the generated Objective-C declarations and you want to and you want your code to be more swifty, you can create a wrapper module around your KMM module using adapter pattern. Of course, this approach comes with the need of writing extra code, but your shared module API will look as you want, and other iOS developers may even don't know that we are using a Kotlin library. I know that this approach is I think widely used among our adapters, so the choice is yours. And as you can see, improving exports in Kotlin code to Objective-C, which will also improve using Swift for Objective-C, is one of the goals for the next Kotlin version. This is the issues from our roadmap. And the next potential issue, and maybe you've heard about it, is Kotlin native compile time. It can become a serious problem if your project is rather big and your developing process includes a lot of small iterations of modifying your business logic, your shared code, and building it for running on iOS. You can minimize the negative effect of this by using some practices to decrease the number of rebuilding app for checking if it works correctly on iOS. For example, there are already a lot of useful multi-platform libraries. One of them is Napier logging library. And comprehensive logs with different levels will help you to debug your application quickly, and you will maybe decrease the number of rerunning iterations. Please use the benefits of code reuse. You can run and debug your code on Android because, well, it's the same code, except some corner cases such as working with concurrency, which we discussed earlier. For such cases, having tests for common code would be very helpful, and you can run them on both platforms on pull requests, for example, somewhere on your CI. And of course, Kotlin team is working hard on this issue, and optimizing the compile time is on the top of Kotlin native team's backlog. By the way, some of the improvements will be already available in the nearest minor Kotlin release. And organizing team can also be challenging. As software developing, it's a team game, with each critical decision needing the approval of all team members. And I think integrating any cross-platform technology will significantly affect the development process for your mobile application. So before you start integrating KMM in your project, you'll need to introduce your team to the technology and guide them gently to see that it's worth adopting. On our documentation portal, we have a special article with some recommendations on how to do it. For example, how to get rid of this, pre-existing bad feeling about cross-platform applications, like they're all slow, or something like that. Or how to provide continuous support for your teammates in this difficult adaptation period. To start using KMM in your team, you need to answer some organization questions. For example, who will be the owner of a shared code? iOS team, Android team, or both? Where it will be stored? Will you use monorepo or multi-repo? How it will be delivered to the project? And what parts of your application do you want to share? And the main advice from all our adopters: integrate KMM gradually, as it allows it. You can start, for example, with a tiny new feature, or by using it in some internal project, for example. This approach will allow you not to stuck with lots of unanswered questions, and will give you time to make decisions carefully. A good source of knowledge and inspiration for such kinds of decisions is the first-hand experience of KMM production users. On our documentation portal, you find not only the list of the teams, but also their stories about how KMM is used in their product, and what profits and gains have them experienced since adopting KMM. So we saw what challenges you may face on your way of integrating KMM. But please, don't be afraid. Kotlin team is working hard to make KMM users' life better. And it's important that you won't be alone. Community have been successfully overcoming these challenges and share their experience all the time. And about community, recently we conducted the first big Kotlin multi-platform survey. And for the last step of our today KMM journey, I want to share with you some insights to give you the fullest picture of KMM world. With the majority of users having more than 5 years of development experience, we can conclude with that Kotlin multi-platform is interesting to those who have a lot of knowledge in programming. And I can't deny that KMM has a steep learning curve. I love this metaphor a lot. I've heard it somewhere, I think I've read it somewhere in Slack. Flutter and React Native is a pre-made cakes. And all you need to do is just go, buy and admire the taste. But of course, there is always a risk that you won't like one of the ingredients or how they go with each other. And KMM is more like a cake recipe. You can configure it in a way you want to get something amazing, but you definitely need some cooking skills to do it. The lack of education materials is a huge blocker to start for developers with less experience. And with the release of the KMM documentation portal, we see that situation is changing and the number of developers with less experience is already growing. Kotlin multi-platform is a popular choice for creating open source libraries and internal SDKs, but not only. It's trusted more than 40% of our users to build user-facing applications with a shared code. And one of the most popular questions I'm often asked sounds, is Kotlin multi-platform ready for production? And the next popular is about, could I write Flutter apps in Kotlin? So about production, according to survey results, more than half of the users have already released an application with a shared module, KMM module, or are about to release one in the near future. So KMM alpha status is not a blocker for going production, but you definitely need to be ready to spend some time for migrations to a newer version, because the technology is evolving and some changes could be made in order to satisfy users' needs. The majority of users used multi-platform project IDE Wizard to get started, which I also mentioned, and I think you should also give it a try. And the last and my favorite one. KMM was designed to help developers reuse their business logic between mobile platforms. And we can see that all that kind of stuff, like networking, data serialization and synchronization logic, some algorithms, are the most popular options here. But what we also can see, that the original purpose is not stopping developers from using KMM for other parts of their apps. For example, for presentation layer, presenters, UModels and UI state options here. My teammate and I are developing an open source sample application. It will be full working application published on App Store and Google Play, and we're using Redux-like architecture there, and we're sharing application state also with KMM. And there are even adopters who are using Kotlin for all code base, so it's almost 100% shared. They've written a multi-platform library that provides a declarative UI and application screens management in common code. And as far as I know, they even have a production apps based on that library. I would say it's more like the unusual way of using KMM, but the main conclusion here is that this is real flexible technology and you could cook everything, almost everything, based on this cake recipe. So why today is a good state to start? KMM is now in alpha. This means that the Kotlin team is fully committed on improving this technology and helping it evolve. And it's also a signal that the product will develop quickly from here on. Going alpha means that everything is ready for you to start using KMM to share business logic, or even more, between mobile platforms. You can create a new project or easily integrate KMM module into existing ones. And I think the important thing about it that in both scenarios the work can be done with minimal cost, and you can always go back to fully native development if something goes wrong. The community is growing really fast, and you can influence the development of the whole ecosystem by participating in it and by creating some amazing multi-platform libraries. And the last question, what's the best way to start? The documentation KMM portal, which I mentioned a lot today, is your trusted resource when you're working with KMM. You will find content for all levels of expertise, from tutorials to get you started to more advanced development topics. It contains useful information about common tasks like organizing networking and data storage layers, and even organizing the development process around KMM. If you are looking for new ideas about the benefits of using KMM in your application, I suggest you to learn from a first-hand experience of a variety of teams, for example, VMware, Quizlet and Yandex, who are already using KMM in their products in the case study section of our portal. And please try the new, I think it's not new, it's already not new, KMM plugin for Android Studio. With the new wizards and iOS integration, you can create a new KMM project in a few clicks, really 3 clicks, and start exploring all the KMM features. So thank you very much for your attention, and have a nice Kotlin.
Brilliant. Thank you so much for a wonderful talk. Very, very comprehensive. Lots and lots of information there. Just ask a few questions. So question number one, I mean, personally, I didn't realize how important this was until last year, when we were talking to a couple of potential clients, and they said they'd gone Kotlin just for this, you know, so they'd adopted Kotlin purely for KMM. So first question, and maybe one you've already answered, you know, is KMM probably one of the most important things in Kotlin going forward? So in the same way that in the beginning it was null safety and then DSLs and then coroutines and so on, is KMM the new killer feature for Kotlin?
I would say yes, but I think I would spread the answer, not KMM, but the main idea about Kotlin multi-platform capabilities. And we just choose the mobile direction, the mobile community, because we know about Android application a lot, and you know, mobile cross-platform is a really hot topic today. So that's why we decided to focus on one direction, because focus, well, it's important. But all multi-platform stuff is important for Kotlin, and it's really one of the key features of Kotlin. So let's not forget about Kotlin JS, for example, or some other stuff.
Cool, very good. And then is Gradle the only build tool for KMM?
Yes, right now, yes, Gradle is the only one. So this is also the popular question, especially from iOS developers, like, can I learn Gradle in 24 hours? And no, we're constantly thinking about how to improve life of KMM developers by maybe decrease the number of things you should do directly by configuring some Gradle file. So we realize that it's a huge thing to start doing KMM. Yeah. So, but Gradle is the needed one.
Yes, it will get you there in the end, absolutely.
True.
And then whenever you're using the Kotlin native threading model on iOS, does that impose any limitations in terms of resources, amount of memory, number of threads? Does it add any hard limits at all?
Yes, there are some limitations. First, with current version of coroutines library, which is called multi-threaded coroutines, you can use only one background thread. And the other limitations, they all covers this feature about that you need to freeze that objects which are passed through multiple threads, they are freezed. So it implies the way how you write your code.
Okay.
So
yes.
yeah.
Yeah. And what limits are there when you're using coroutines then on iOS?
Well, you can't directly use coroutines on iOS, but you can use them in your Kotlin code, in your Kotlin shared module. And first thing you should remember, just use if you want to use coroutines multi-threaded on iOS, you should use the separate version which I mentioned. Yes, they would run only on one background thread. And yes, I think that's the most important limitations.
Cool. And then I think we only have time for one more question. So the design of the user interface itself, would that still be done with the regular design tool that you would use in Swift or Android?
Yep. As I mentioned, the thing that KMM doesn't impose any limitations on how you develop the UI is the benefit, because well, we know how important the UI for mobile users, and that's why you just use all your basic stuff for it. Everything you want. You can use Swift UI for iOS, for example. You can use Compose for Android, and just don't think about any restrictions.
Cool, brilliant. Thank you so much. So absolutely wonderful talk. If I could bring on our other presenters as well. So one more. Yay. So sadly, I think we're out of time, but just before we go, is there anything that any of you would like to ask one of the other presenters, or any final comments or anything that you would like to make? Going once.
I think it was a great presentation. It's so cool to do like virtual talks and still be able to meet people from across the world, even though we're not in person. So really like awesome job putting this together too. I'm so happy to be a part of it. I'm so glad we got to present.
Very good. And listen, thank you everybody, because I know this was either very late or very early, you know, for everybody. So so thank you so much. Look, so we'll leave it there. Thank you very much indeed. And thank you to everybody who attended, and hope to see you next time. Bye.
Thank you. Bye-bye.